Hello students, welcome to video lesson 9.4b. We're going to continue talking in this video about solving quadratic equations by factoring, but I wanted to take some extra time and set aside a chance to review the window method for factoring some more complicated quadratic equations. I know it's not everybody's favorite thing to do, but it can, if we practice and we get really good at it, it can be a lot easier than some of the other strategies we'll talk about in this chapter to solve quadratic equations. Before we get into the window method, I just want to remind everybody sort of what our plan is here. Okay, so when we have a quadratic trinomial that is equal to 0, right? It is very, very important that it be equal to 0. So when we have a quadratic trinomial equal to 0, if we can factor that quadratic trinomial, we can then use the zero product property to find the solutions to that quadratic equation, okay? But I do want to let everybody know that it's not always true that a quadratic trinomial can be factored into those two sets of parentheses. There are a lot of them out there that can't be. And here's one example. Okay, so this quadratic equation, x squared plus 6x plus 10, actually cannot be factored, because what we would have to do is we'd have to find two numbers that multiplied together make 10 and added together make 6. Right? Multiply to make 10 and add to make 6, but the only options for multiplying to 10 are 1 times 10 or 2 times 5. Right? And if I add those together, they do not equal 6. So what we would say then for this is this cannot be factored. Okay, but it's important to note that cannot be factored is not the same as no solutions. Okay, we talked a couple videos ago about equations that had no solutions when we were square rooting the negatives, if you remember. Cannot be factored is a different thing, because we will later on talk about another strategy, actually a couple more strategies to solve quadratic equations. Okay, so for now, if you come across one that can't be factored, we're just going to say that can't be factored. We don't know how to solve this type of quadratic equation quite yet. Okay, so just be aware that that is also a possibility, that quadratic equations may not be able to be factored. So in our last video, we talked about quadratic equations with a coefficient of 1 on the x squared term. And then we also did show an example where we had to factor out a greatest common factor first. And that turned into a different sort of factored form that we could still use the zero product property for. But we do also know that we have the window method as a way to factor more complicated quadratic equations. So that's what we're going to look at now with this particular example. Okay, so we have this quadratic equation, 3x squared plus 4x equals 15. The first thing that I want you to notice is this number right here, right? It's on the other side of the equal sign from all of my quadratic stuff. This number is not really what I want to see there, right? Because in order to use the zero product property in my factoring, I need this quadratic equation to be equal to 0. So I actually need to move stuff, minus things from one side or the other in order to move everything to one side of the equation, so that one side of my equal sign equals just 0. So in this case, if I minus 15 from this side, this will turn the right-hand side of my equation into 0. So 15 minus 15 is 0, all right? Of course, I have to do that on the left side as well. And because the other side just has x squared and x terms, I can't actually combine the minus 15 with anything, right? I don't get to minus 15 from 3 or minus 15 from 4. It just shows up as an extra term in my quadratic equation on this side. So it becomes this, minus 15, okay? So just be aware that if the quadratic equation is not currently equal to 0, you're going to have to minus or possibly add things on both sides so that one side becomes just 0. Right? And generally, If you had, for example, the quadratic equation, let's say x squared equals 2x minus 3, we want to keep the x squared term positive. So when we move things from one side of the equal sign to the other, we always want to sort of move things towards the x squared. Okay, so in this case, we're going to minus this 2x and we're going to add 3 so that the 2x's go away and that the minus 3 goes away. And so it would show up then as x squared minus 2x plus 3 is equal to 0 because this side, everything's now gone. Okay, but that's actually not an equation we can factor either. So we're going to focus back in on our window method example here. 3x squared plus 4x minus 15 equals 0. So I'm going to go ahead and try to factor this with the window method, and I'm going to try to make this quadratic equation into those two sets of parentheses, okay? So if I make myself a window over here, and I start filling it in with my 3x squared here and my minus 15 here, if I multiply those together, I get negative 45, right? Technically negative 45x squared. So I need now two numbers to fill in the rest of my window that multiply to make negative 45 and that add together to make 4. Okay, so they have to multiply to negative 45 and add together to get 4. So I know one has to be positive and one negative because they're going to multiply to a negative. And because this is a plus 4, I know the bigger number has to be positive. So if I start thinking about numbers that can multiply to be 45, I could do negative 1 and positive 45, but when I add those, I don't get 4. I could do negative 3 and positive 15. When I add those together, I get 12. I could do negative 5 and positive 9, and when I add those together, I get 4. Oh, and that's exactly what I want, right? So negative 5 plus 9 gives me 4. Negative 5 times 9 would give me my negative 45. So I now know the two numbers that need to go in the other two boxes of my window. So this becomes negative 5 with an x, and this one becomes 9 with an x, okay? So now that my window is full, I'm going to try to find my greatest common factors of my rows and my columns, right? I'll start with the rows. If I go across this top row here, I have 3x squared and a negative 5x. So I'm going to deal first with the numbers, 3 and 5. 3 and 5. What can I divide 3 and 5 both by? Well, the only number is actually a 1, okay, which in the end is not going to need to be there. But 3 and 5 don't have any other common factors. Nothing else can divide into both of those. Both of these boxes do have an x, so I'm going to pull out an x as well. And just as a quick reminder, even though I have a minus 5 here, we never pull out a negative for the x term, right? We never do that. So this greatest common factor of this row is just 1x. Now, if I go to the bottom row here, 9x and a negative 15. 9x and a negative 15. Well, first I deal with the numbers, 9 and 15. 9 and 15, both of those can be divided by 3. So I pull out a 3. The negative 15 does not have an x on it, so I can't pull out a variable. And then to decide if this should be a negative, I just look at the x number, right? So the x number, remember this sort of is the key right here. Is this number negative or positive? That number is positive, so I'm going to keep this 3 as a positive 3, which means one of my factors from this quadratic trinomial is x plus 3, okay? The other factor is going to be whatever I get for my greatest common factors going up my columns here, okay? So 3x squared and 9x, if I look at this left-hand column, 3 and 9 in terms of the numbers, they can both be divided by a 3. And these do both have an x, so I'll pull out an x as well. So 3x is going to be the first part of this other factor. Then my other column says negative 5x and a negative 15. I have negative 5x and negative 15. In terms of numbers, 5 and 15 can both be divided by 5. The negative 15 does not have an x, so I don't pull out an x here. But look at my x number here with my negative 5. Because this number is negative, I'm going to make my 5 that I pulled out negative as well. So my other factor becomes 3x minus 5. Okay, so I have now my two factors for my quadratic trinomial from the window method. The other side of my equation still says equals 0 because I made it say that. And now think what this allows me to do, right? This is now my equation. I'm going to get rid of this guy so they're not confused. And this is two sets of parentheses, two separate things multiplied together that equals 0, right? And so what does the 0 product property tell me? Well, it tells me that x plus 3 might equal 0, or it tells me that 3x minus 5 might equal 0. And those are the only two options, okay? And these two equations are then going to lead me to my solutions, my two values of x. And remember, when we are answering these questions that ask me to solve for x, I'm in the end going to want to say x equals this, x equals that, okay? So from this first equation, from this first factor, I'm just going to minus 3 on both sides, and I'm going to arrive at my solution. 0 minus 3 is negative 3, so x equals negative 3 is one of my answers. For this factor, or for this equation that came from this factor, I'm going to first add 5 on both sides, and I'm going to get 5 on this side. That's going to go away, and the other side's going to say 3x. Then I'm going to divide away the 3, and this fraction cannot be simplified or reduced, and I can't do 5 divided by 3 very nicely. So I am just going to actually leave 5/3 there as my solution, okay? So 5/3. So this is one answer, x equals 5/3. This is my other answer, x equals negative 3, okay? So once we have it factored, nothing is different than the last video. But just do remember, and this was sort of a little refresher for you on how the window method works, and also sort of shows you an example where we have to do a little work first to make one side of our quadratic equation equal to 0. And if we move everything to one side and then it's a factorable quadratic, as we get more practice, this will become a relatively easy way to find the solutions to a quadratic equation. If you have any questions about the window method to factor or moving things over so that one side is 0 or anything else in this video, do please reach out to me and let me know. Otherwise, that's all I have for you right now, and we'll talk to you soon.